Thanks again.
Perfect.
And moving right along, let's welcome Jose Romero, VP of Product and Platform at X Factor. He'll be presenting Precision GTM, the RevOps lever stack. Say, how are you doing?
Good, good. Thank you for having me here today.
Our pleasure.
So it's a pleasure to be here. That last session with Aaron was very good because I think there's a lot of overlap between what you're going to hear me talking about and his point of view. So I think we agree in a lot of things. But so today we're going to talk a little bit about moving away from GTM firefighting to strategy. To talk a little bit more about a new framework for running GTM in a very surgical way using AI. So what Aaron was saying, I had a chart for the Gartner has identified that about 13% of a CRO's work week is spent firefighting. Sorry, doing strategic work. 87% firefighting. So GTM teams today are very reactive by nature. So that is a big problem, and it's something that needs to change in order for teams to be able to meet and exceed their goals. So what does that mean more precisely, right? So RevOps, it's really a three-legged stool, right? It's sales, marketing, customer success, and their challenges. If we treat things separately as three different functions, this stool starts falling apart because it's one interconnected system. So, for example, if we decide to push sales to close faster, it destabilizes the whole system, creates bottlenecks, wasted resources, because the data and in the actual system is not disconnected; it's all interconnected. So it drives inaccurate results and inefficient outcomes. So what are these levers that we talk about, right? I mean, I think a lot of us on this call are very familiar with them. I mean, I've listed some of them here, but it's a mix of marketing, sales, customer success, and financial levers from top funnel, qualification, velocity, conversion, retention, expansion. So the problem is, they're all intertwined. So how do you handle that? What ends up happening is that we end up creating what we call a growth guess gap. The the you know As I've been both building AI and ML systems at companies like Amazon for over the years, and also been in go-to-market for companies like Verisign, I've always bumped into this problem. We build AI models, whether we were building AI models to build to running GTM teams. The problem is always the same. We're forced to take multi-million-dollar guessworks in with using brittle spreadsheets. So the question is, how do we do this differently? I think we can and must move from this guesswork to a more engineered approach to growth. So what do we mean by that, right? So let's just take an example. So your team does a heroic job of shortening the sales cycle, and we all think that's a win. But if the marketing lead velocity doesn't change, then your high-performing reps are now idle for a month of the quarter. So that's what I call a bottleneck in action, right? So it's a GTM system. It's the system is as only as fast as the slowest part. So you speed up sales cycle. Now you find where your next bottleneck is at, and that's the thing you got to fix next. So how do you find those bottlenecks? How do you proactively adapt to those things? So as a way to help move things along, I've put together a PDF that I can share with the group. So there is a way to start closing this gap today. And if we take a couple of examples that I'll share on this PDF. You can use a tool like Claude Desktop, for example, in a Salesforce MCP server. And then instead of just chasing your reps or relying on run rates, these 5 prompts that you see here leverage generic LLMs as a smart calculator in a way to provide far deeper insights into pipeline health, lead conversion, stall opportunities, engagement, etc., um, to have a more nuanced projection on revenue impact. So these are practical, immediate things that you can do today. And at the end of the session, I'll share that PDF, and you can take a quick look. What I'll do is I'll just pivot over really quickly so you can take a quick snap at it. But again, Julia has the PDF and she'll share it. So these prompts, for example, this is a pipeline health prompt. If you connect, let's say you use Claude Desktop or any tool that leverages MCP, you could connect your Salesforce instance to it. You create an integration user, and you're off to the races. And then you can start asking questions. So in this example, I'm doing an analysis trying to figure out the gap in opportunity creation. So I've asked it a few very pointed things like the last 12 months I want to exclude bottom and top um, uh, outliers by amount and sales cycle, and I want to predict what new opportunities need to be created between today and the end of the fiscal year in order to hit my target. And I also want to predict the number of opportunities that will be created between now and the end of the fiscal year. So basically, what am I targeting as a opportunity generation right now versus how much do I need? Am I going to have a gap? And it's, this is different from what you can do with Salesforce. Salesforce will only go so far, right? It cannot do forecasting, it cannot do predictive analytics. So when I ran this particular one, it gave me a full analysis, and we're using mock data on a Salesforce instance. But it went deep, right? It went ahead and identified that, I give an example of an $8 million target. It's identified how many opportunities I needed. It identified what my rate of opportunity creation needs to be versus what it is. And I figured out, what my opportunity creation gap is. So this is what I mean about a growth guess gap. So this is using mathematics to come up with a mechanism to identify where your bottlenecks are at. So with this, I provided 5 different examples, one for lead conversion, bottleneck identification, and many others. I'll share this with the group, and if anybody, of course, has any questions on the doc, you may be more than happy to answer them. But so this is great. I mean, this is fantastic. It moves you away from the crystal ball and the prayers and in the endless scrolling of spreadsheets and megabyte size spreadsheets that are break down after certain usage into a more modern, faster way of understanding not only what's happened but what will happen. So, growth AI, I think, is certainly a better way than using spreadsheets. But then there's still some challenges with using off-the-shelf AI, right? So it's a huge step forward from spreadsheets, but there are some limitations that you can see, right? The systems aren't talking to each other. All of this data is not necessarily speaking to each other if it's not sitting in the same place. You still have to provide some context and in the form of averages and other things that it may not have available to it right immediately. And most importantly, these tools cannot simulate what we call second order effects on your decisions. They can't answer questions like, what happens to my sales capacity if this marketing campaign succeeds, right? For that, we need a new class of AI, something that is beyond what a standard off-the-shelf AI can do. So, here's where, your AI becomes much more. It's not just any AI. We're talking about not a generic chatbot. We're talking about an AI that is purpose-built for the revenue engine. So it's trained on specific dynamics for sales capacity, pipeline velocity, marketing campaigns, et cetera, et cetera. This is what we call a new emerging category we're calling growth AI. And this is designed to overcome all these limitations that generic AIs don't have by understanding the causal relationship in your GTM system. So what do I mean by causal relationship, right? The first level of AI is predictive AI. It's the first level of intelligence. It's powerful. In the PDF that I'll share has leverages that in many of the examples that I share. It analyzes your historical data and forecasts what will happen next. It can give you more accurate sales forecasts or identify customers at risk of churning, but it has a critical limitation. It operates in correlation. And a speaker earlier talked about correlation versus causation. So I'm going to hit that same topic now. A predictive AI might tell you that a rep who, say, flies to meet clients has higher win rates, but it cannot tell you if the travel is what cost the win. Right? So that's the difference between correlation versus causation. So what caused the improved wins? Is it the flight, or is it something else? Versus causal, this is where the big change is. It goes deeper into understanding cause and effect. So you think about the question: if I pull this lever, what is true and causal impact to the entire system? What will actually, by moving this lever, what is the trickling effect? So this is how we move from forecasting to simulation. So we can model complex trade-offs like hiring more reps versus increasing campaign spend, and see the probable outcomes before we commit a single dollar. This is how we find out which lever truly moves the number, because at the end of the day, the business succeeds if they can hit the revenue goals. So let's go a little bit deeper into simulation and what I mean by simulation. So let's take a real world example in a complex scenario. So you have a CRO, say, that's worried about hitting an annual number, right? And asks you as a RevOps person to model the impact of 4 different improvements across the entire go-to-market engine. In this example, they're asking to modify attrition, retention, win rate, and MQL to SQL conversions. So, and go figure out if that's the right combination. If you try to do that on a spreadsheet, it's pretty much impossible. The interconnected dependencies are too complex. But if you use an AI system that is purpose-built for RevOps, you will be able to achieve that. So you're not guessing anymore, you're simulating. You adjust these levers, and the system instantly models the compounding effects across the whole revenue engine. It tells you not just the potential revenue lift, but also that you'll close the gap in 9 months, that you will need an 8% increase in pipeline to support the higher win rate. It'll factor all of these things for you. So this is the big difference between a panic guess, because the CRO asks you to do this, to a precise data-driven approach. So what does this look like in the real world? I'll just pivot to an example here. We're looking at a capacity performance dashboard where you can simulate what you could do. What would happen if you, say, increased your average sales price or you decreased your attrition, and when you move these levers in real time, your outputs change. You're seeing that by modifying your new business or increasing your new business average sales price by a percentage, it changes the whole system. You modify your let's say your America's sales attrition, you decrease it. It also modifies the whole system. You decrease your ramp time, it modifies your whole system. So it's a way to in one place be able to model all these different possible scenarios. So but we need to go further, because there's so many levers, kind of more than 30 levers. What is the right combination? What are the right levers to move in which way? Right? There isn't a single answer, to be honest. Right? It all depends on what the business can achieve, given its resources, in its scenarios, and where it's at right now in their history. So if we then take this approach and build a multi-agent system across it, it can actually decipher a set of potential scenarios and provide them to the user. So this isn't a solution to replace RevOps. It's a solution to elevate RevOps and even amplify it. So you're moving away from the mundane manual analysis to something more automated. So it frees RevOps teams to focus on high-value strategic work by designing, say, better playbooks, handling complex exceptions, even fine-tuning some of the AI responses. So your job as a RevOps person becomes now you become the chief architect of the company's entire revenue generation engine. Another interesting point to share. This is a slide that we put together with the Revenue Operations Associates. They are the company who put together the RevOps book and are offering the Revenue Operations certification. And they are in this chart showing the top reasons why GTM teams are failing is because RevOps are not focused enough and don't have the right tools to drive these top growth drivers that are listed in here. So with a growth AI system, you can now spend more time on strategy and less on firefighting. So these are the things that could be more impactful if you could move away from firefighting into more strategic planning and becoming that chief architect of revenue. So you've heard through today a lot about agentic AI and systems that execute tasks, and that's the future, and it's powerful. But agentic execution is only as good as the strategy it's executing. So the focus of growth AI is to go one level above. It's empowering you to engineer the strategy itself. So other systems are going to focus on automating the how. We use causal AI to help you master the why and simulating what-ifs. So we believe the greatest leverage comes from not just doing things faster, but from deciding to do the right things in the first place. So instead of guessing, just get it right the first time. So you can simulate go-to-market trade-offs. You can close this growth guess gap, and you replace your spreadsheets with an always-on strategy. Moving beyond just automating tasks to truly engineering your growth. So that's what precision GTM is all about. Is just confident, coordinated execution using causal, not correlation. And with that, I will stop and answer any questions.
Phenomenal session. Let's get into the questions. So one of the questions that keeps coming up is, most of our GTM trade-offs still happen in spreadsheets and back channel threads. What actually changes when you move to AI simulations?
So the spreadsheets, so there's many data sources where this information is kept. It's kept, to your point, on spreadsheets, on conversations, on chats, on emails, on even calls that are transcribed with Gong. So the main difference here is that in order for you to be able to appropriately simulate, right? AI systems are only as smart as the data that they have access to. So feeding it all the right data in order for it to be able to simulate things properly is the only approach. But more precisely on the question here, right? I mean, there's 30 some variables in go-to-market. So the key thing that we're doing here is trying to simulate the correlation and the causation of these variables. So the mathematics basically behind and the science behind growth and how moving one lever impacts the other lever. So it's a little bit less about the where data is stored and more about how to apply mathematics to the data in order to come up with reliable outcomes.
People are asking, what's the most surprising insight a team uncovered running these simulations in your practice?
Yes. So we had one customer, in essence, identify that the board number that was being provided was just not achievable with the resources they had. So they had a number over their head, and no matter what adjustments they could make, there was no way for them to actually hit that number. So uh, it uncovered, in essence, gave that team the ammunition to go back to the board and say, based on what we have today, we can't achieve this, and may not be able to achieve it in some time, because things like sales rep ramp time are a factor that you cannot really manipulate, right? So if it takes time, in this case, that company, their ramp time was 9 months. Um, Even if they started hiring people that day, they would not see an impact to that number until the following year.
Another question here. RevOps often find itself as a cleanup crew. How does this help move the function upstream closer to decision making?
So, uh, and I'm going to elaborate on the cleanup crew. So things don't go well. They are told, go look into why they did not go well and fix it. So it goes back to the whole firefighting reactive approach that I was talking about earlier. Um, the this approach changes the paradigm completely, because it does two things for you. In real time, it's telling you what are these metrics look like right now. So you don't have to do a lot of spreadsheet work to figure that out. And not only that, it's also looking into the future and it's telling you already what's going to happen before it happens. So if you think about it from the standpoint of um, today, you're basically blind to what's going to happen, and then your door gets knocked by the CRO saying we have a problem. You don't even know what the problem is. They're explaining you the problem. You actually have to figure out what exactly happened, because they're going to explain to you something at a very high level. You got to go deep now, figure it out, and then come up with a proactive response. This, on the other hand, flips the script. You actually know, even before the CRO, what is going on. You're being
Mhm.
proactive now. You're looking at things and going, we're going to have a problem here and here and here. So you go to the CRO and you tell the CRO, we're going to have these problems. What can we do about them? CRO net will never get a surprise, because they already know from the system what the next problem is. So whenever they're having a C-suite conversation, the CRO is never on the hot seat.
Question from Diana. How ready are your typical clients with data to feed this system?
So yeah, that's a typical problem that we hear from our customers. Everybody has a data cleanliness problem. We do have systems behind the data that are actively looking at it and trying to clean it up. Um, for example, in our territory planning component, there are companies that leverage geographic territory assignments, and the accounts may not have all the correct information. In some cases, that doesn't have any information on the geography or where that account sits. So we go and clean that up. We make correct addresses, or we may actually fill addresses. So that's just one example. But across the board, we're looking at the customer's data, and try to clean up as much as we can. There's still things that can't be done by us. They would have to be done by the customer. But ultimately, it's a collaborative approach to getting good results.
Another question here. How do you simulate headcount shifts without overfitting to historical performance?
So I think the question is, you're shifting a resource from one geo to another geo, or
Mhm.
one role to another role, maybe from mid-market to enterprise. Um, so we do a couple of things, right? So we're looking at both that person's performance against their peers. So how's that person performed? So let's say hypothetically, just to pick an example, you have a mid-market rep that is promoted to be an enterprise rep. So they normally get promoted because they've done better than their peers. So we do take that into consideration, but we also calculated an estimated yield for reps across time. So we do a ramp time calculation. How long does it take for a rep to hit their stride in essence? And then what is that stride? Like what is the estimate yield across different tenure bands? So we're looking at say 0 to 6 months versus 6 to 12 months, et cetera. And we do make those calculations. And then whenever a rep gets transitioned, we consider that also in the math.
Huh. Another question here. Super interesting given your background. Say, what, um, so yeah, what breaks first when companies try to build this kind of lever model in house without a purpose built platform?
The first thing that breaks is um, the models themselves. So there's two things that are going on behind the scenes here. So you have both a machine learning model, which is different from an LLM. I think some of the folks in previous sessions discussed that a little bit before. Think about a machine learning system. Uh, Whenever you use Spotify, right? Spotify is making recommendations to you. That is not an LLM, but it's still an engine that is looking at what you clicked on and the things that you did and trying to give you a recommendation on what you might like next. That's a machine learning model versus a large language model, which is, we all know ChatGPT and Gemini and all these other tools. So we do a combination of these. So the first challenge that customers typically have is an accuracy challenge. So they try to clean up their data. They try to come up with a scenario where they manipulate these levers and come with an outcome, but they may not have the the full picture of how all these things are intertwined and the causal effects of them, and then tying that together with an LLM that would give you recommendations. So tying the ML and the LLM together so that they can work together in concert or orchestrate the movement of these levers. That is typically where things fall flat.
Let's say there's a lot of noise and confusion these days about AI, agentic AI especially. Being a product leader, what would be your recommendations to all of the executives watching, GTM leaders? Where do they start? What do they read? What do they do? How do they transition from, a well-established GTM model of running things to this new type of thing that no one else?
Oh, I appreciate the question. Something I think about all the time. So one of the things that I do with our own organization is I'm kind of the AI sponsor, AI evangelist. Um, and then for specifically with my CEO and some of the executives, what one of the things one quote from Sam Altman that I really liked that I keep repeating is I think about a month ago he said that he analyzed the demographic patterns of people who use ChatGPT and noticed that the prompts being used are drastically different between teenagers, 20-year-olds and 30-year-olds. Not He never mentioned 40, 50, 60-year-olds. He just stayed with those and said that 30-year-olds use ChatGPT as a replacement to search, while 18, 19-year-olds are using ChatGPT as an operating system. And then he went in deeper and explaining what that meant. And so, in essence, they are using ChatGPT as somebody to bounce off life decisions before making them. So they're thinking about doing something and they bounce off that idea off that system. So it's not replacing their decision. It's not that they're now having the chat make the decision for them. They're just consulting. They think they have a thought and they're going to go in this direction, and they want to consult with AI on it. I think that's a powerful thought that everybody should consider. Is as you're transitioning into this AI world, we know now that the younger generation uses cell phones differently than the older generation. Same things can happen with AI. And the faster we start adopting using AI, like the younger people, the more attuned we're going to be, the smarter we're going to be.
What do you think they're working on with Johnny Ive?
I can only tell you, these are just I'm just putting together the dots. But the fact that Apple is no longer working as closely with OpenAI um, tells me that they are basically want to put together an AI first device. Honestly, think that 5, 10 years from now, the way that we interface with phones is or devices, just going to call it a more generic term, is different. We're still going to need screens for certain things, but the majority of the time, we're just going to be talking to the devices. And so instead of booking I don't know, let's say that you want to book something in your calendar or send an email, you just tell the AI. So why have to open up your phone and start clicking, clicky, clicky, clicky when you can just tell it to do what you want it to do? And it's learning your preferences anyway, so it's becoming better at understanding how you think. So it eventually becomes an extension of you.
Last question, I promise. What do you think ChatGPT and the alike will turn into a distribution platform?
So, I'm sorry, I didn't catch your whole question. So what do I think ChatGPT and
Yeah, and all of the perplexity, clouds, and the like will turn into full-blown social media slash distribution platforms.
um not sure if I'm answering your question by saying this, but I think there was a an idea of having a super intelligence. And I think that idea is becoming slightly harder to achieve as time passes. So the nirvana moment was we're going to create the super intelligence that is going to do everything. And as they're getting to having these systems be generalizable, being able to say something it learned here and apply it over here, it's becoming hard to impossible. So I think what's going to end up happening is all of these companies are going to pick an area and they're going to excel at that area and drive revenue from being good at that. But this idea of having one company that rules it all because they have control over everything, at least for now, they're having where I think on the research papers that I've read, people are having a hard time getting to that point.
Thanks so much, Jose. Pleasure hosting you. And now it's game side time.